to the calculation. But before we go back to the calculation, let's just do a preview of the concentration of some of the reagents. This is in regards to some of the questions I received in the comment. We are making use of sodium thiosulfate, and from the instruction there, it says dissolve 24.82 grams of it, that is per dm cube. Okay, per dm cube, that is in 1000 cm cube. In 1000 cm cube, because 1 dm cube is equivalent, 1 dm cube is equivalent to 1000 cm cube. All right, so if you dissolve 24.82 grams of sodium thiosulfate pentahydrate in 1000 cm cube, what will be the concentration? This is how you calculate it. Concentration is equal to mass over molar mass times 1000 over volume. Okay, so the mass is 24. Okay, concentration, the mass is 24.82 grams. Then now you calculate the molar mass of sodium thiosulfate, and this is how you do that. Molar mass of sodium thiosulfate pentahydrate. Okay, the mass of sodium is 23, and we're having 2 of it, so 23 times 2, plus the mass of sulfur is 32, and we're having 2 of it, so we say 32 times 2. Okay, plus the mass of oxygen is 16 times 3, 16 times 3 gives you 48, plus 5 times water. The mass of water is 18, hydrogen is 1 times 2, plus oxygen 16 to give you 18. Okay, so 5 times 18. So when you sum everything here, the total mass you get is 248 grams. Okay, 248 grams. So what you do to 248.18 grams, or approximately you can just say 248 grams of sodium thiosulfate. So that's the mass. So here we have 248.18 grams of that's the mass, the molar mass of it. All right, times 1000 over the volume. The volume you are dissolving it in 1000 dm cube. 1000 dm cube. So when you do this one, you have 0.100 mole. Okay, that's the concentration of sodium thiosulfate. Then we'll move over to iodine. Iodine says dissolve 25.4 grams of iodine in 6.0 grams of potassium iodide. Okay, I told you, iodine is non-polar, and as a result of that cannot dissolve in water, and that's why we are adding potassium iodide to it. Okay, when you add potassium iodide to it, it gives you potassium triiodide, which is very soluble in water. So this is the equation: potassium iodide plus iodine. Okay, it gives you potassium triiodide. So what they are asking you to do, add 6 grams of potassium iodide to iodine in water, then you dilute to 1000 dm cube. But we all know that the 6 grams of potassium iodide is not sufficient to dissolve the 25.4 grams of iodine. Okay, if you notice, if you observe, when you add it, you still have a large mass of iodine left in the solution. So what do we do now? If you go by calculating using 25.4 grams of iodine as the mass dissolved in 1000 dm cube, you will arrive at 0.1 mole also for iodine. But that's not the case. According to my own point of view, not all the mass will dissolve. From the stoichiometry of the reaction, we can get the amount that will be dissolved. Okay, we know that if you calculate the mass of potassium iodide, you will have 166 grams of potassium iodide react with 254 grams of iodine when calculating their mass. Okay, in other words, 166 grams of potassium iodide need an approximately of 2.54 grams of iodine. All right, then 6.0 grams of iodine will need how many? If because multiply, you have 9.18. okay, so this is the mass of it that is likely to be dissolved out of this 25.4. so me, I'm going with this as the mass dissolved in 1000 dm cube. So I will calculate my concentration equal to the mass, same formula, mass, which is 9.18 grams over the molar mass. The molar mass of iodine, okay, the molar mass of iodine is 254 times 1000 dissolved in 1000 dm cube diluted to 1000 dm cube. So if you do this, your final answer becomes 0.0336 mole of iodine. This becomes the concentration of iodine. So me, I choose to go with this one. You may want to go with the 25.4 grams dissolved in it. That's if you choose to do that. Okay, so this is our concentration of sodium thiosulfate, while this is our concentration of iodine according to my own perspective. Yes, question number 1. AN is a solution containing 9.18 grams of iodine per dm cube. BN is a solution containing 6.205 grams of sodium thiosulfate oxyhydrate. Take note, the ox there, which is the water of crystallization, is unknown, and which you may likely be asked to calculate in 250 cm cube. Put BN in the burette and titrate against 20 cm cube or 25 cm cube of AN using starch solution as the indicator. Tabulate the burette readings and calculate the average volume of BN used, which is the sodium thiosulfate. From your result, calculate A, concentration of AN in mole per dm cube, B, concentration of BN in mole per dm cube, C, amount of iodine in 25 cm cube of AN used, and D, the value of X, which is the water of crystallization. Then hence, write the formula of sodium thiosulfate as hydrate. Alright, over to the calculation. The first question there says calculate the concentration of AN in mole per dm cube, which is the concentration of iodine, and the question says AN is a solution containing 9.18 grams of iodine per dm cube. That is 9.18 grams of iodine per dm cube. So what's the concentration of AN, which we've already done before? Concentration, the formula is equal to mass over molar mass times 1000 over volume. Okay, and the mass is 9.18. the molar mass of iodine is 254 rather, times 1000 over the volume per dm cube. Dm cube means 1000 cm cube equivalent. Okay, when you do this, your answer becomes 0.036 mole of iodine. Now back to the next one. Calculate the concentration of B in mole per dm cube. Before that, they will definitely give you the equation for the reaction. This is the equation for the reaction: 2H2O3 plus the iodine will give you sodium So this is the equation for the reaction. All right, and this is our oxidizing agent. Whereas this is our what? Reducing agent. So if you want to calculate the take note, this is our AN and this is our BN. If you want to calculate the concentration of BN now in mole per dm cube, because the question say BN is a solution containing 6.205 grams of sodium thiosulfate X hydrate in 250 ml. Alright, so this is how you do it. CAN, alright, VAN over CBN VBN equal to NAN over NBN. Okay, where our CAN is the concentration of the iodine, which is 0.036 mole, while VAN is the 25 cm cube of iodine measured into the conical flask. Okay, CBN, which is the concentration of thiosulfate we are looking for, unknown, and VBN, which is the average volume of thiosulfate we used from the burette, from the table we calculated, which is approximately 18 cm cube. Then our N number of moles of iodine AN is 1. Then our number of moles of BN, which is thiosulfate, is 2. Alright, so now let's substitute into the formula. CAN is 0.036 times VAN is 25 all over CBN, which is what we are looking for, times VBN, which is 18, equal to NAN, which is 1 all over 2. So if you make CB the subject of the formula, it becomes CB equal to 0.036 times 25 times 2 all over 18, give you 1.8 over 18. Then this one gives you 0.100 mole of CB, which is sodium thiosulfate, which is our sodium thiosulfate S hydrate. This is the concentration of our BN now, CBN, okay, which is the CBN we have here. Next on our list is the C part of it. To calculate the amount of iodine in 25 cm cube of AN measured, this is the formula. It's a very simple thing. The 25 cm cube of iodine times the concentration of iodine, which is 0.036 mole per dm cube over 1000. Okay, so when you do that, the answer you have will be 0.0009 mole. We are over to the last one, the value of S, which is the water of crystallization. First, this is what you do. You calculate the mass concentration, of sodium thiosulfate S hydrate, and this is how you do it, which is the grams, 6.205 grams, okay, times 1000 cm cube over the 250 ml, 250 cm cube. When you do that, you have 24.82 grams. Next, you calculate the molar mass of sodium thiosulfate. Molar mass of sodium thiosulfate. Okay, the mass of sodium. When you calculate the molar mass of this one, take note of this unknown, we cannot get the total. mass. Sodium is 23 times 2, 23 times 2 of it, plus sulfur is 32, 32 times 2 of it, plus oxygen is 16, 16 times 3 of it, okay, plus water is unknown here. The water of crystallization is unknown, but the mass of water is 18, okay, with the unknown water of crystallization which we are looking for. When you do your calculation here, you have 158 plus the 18s, which is the unknown. Take note, water is 18, oxygen is 16, hydrogen here is 1 times 2, 2, 16 plus 2 gives you the 18. So this is the molar mass of it. We cannot get a total because we have an unknown variable here, which is S, which is what we are about to look for. Now, to get the value of S, we use this formula: concentration in grams per dm cube is equal to concentration in mole per dm cube times molar mass. Right? If you make the molar mass subject of formula, we have molar mass equal to concentration in grams per dm cube over concentration in mole per dm cube. All right, now what's the molar mass, which is this one we have here? 158 plus 18 is equal to concentration in gram per dm cube of sodium thiosulfate was from our calculation here. This is the mass concentration, okay, that we calculated is 24.82 grams over the concentration in mole per dm cube, which we have already gotten to be 0.100. Okay, so if you divide this, you have 158 plus 18s. When you divide this, you have 248.2 grams. Okay, so what you do here now, you collect like terms. So we have 18x equal to 248.2 minus 158, and when you do that, you have 18x equals to 90.8. all right, so we divide both sides by 18 to have the value of S. So here 1, so if you divide this, you have 5. Okay, so S is 5. So then now the formula becomes sodium thiosulfate pentahydrate, because it is 5, the value of S is 5, pentahydrate. I hope this helped. Please, if you have any question regarding this, you can drop your view about this in the comments section below. Thanks.